Well, hello and welcome once again to the Waters and Stanton video channel. Winter's coming on now, it's getting cooler, sun is getting lower in the sky, and it reminds us, antennas. Mustn't forget to sort my antennas out before it gets too cold, before the snow falls, before the ice forms, before it's just too cold to work outside. Well, this video is really for newcomers that want to get on the HF bands and really want to think about having a multiband antenna, because as good as it is to be on one band, it's always the grass is greener in the next field, isn't it? You're on 20 metres, you think, oh, it's closed and I should be on 40 metres, or you're on 40 metres and you think, oh, gracious me, that working DX on 20 metres, my antenna doesn't cover those frequencies. Well, why not have an antenna that covers more than one band, or possibly all the bands? Wouldn't that be great? So what I'm going to do now is just take you through some options. Now, none of these figures that I give you are precise measurements. There are formulas to measure the length of wire for an antenna, and you can get those on the internet. But I'm going to take you through some of the options that you have for a horizontal wire antenna in a smallish garden. Almost all ham radio antennas start off in some way, shape or form with a dipole. A dipole basically is two legs fed in the centre with a piece of coax, and the current distribution on the dipole is rather like that. Maximum current in the centre, minimum current at the end, and high voltage. The maximum current in the centre is quite important because that's where the maximum radiation occurs, and a dipole covers a fixed frequency. There is a simple formula for calculating a half wave in meters, and that is 150 divided by the frequency in megahertz. It's a very simple formula to remember, but in fact it needs to be adjusted because the length of the wire is affected by what we call the end effect. So the answer to that should really be multiplied by 0.95. That will give you the approximate length, but bear in mind that whatever answer you get, you will probably need to adjust slightly because of surrounding objects. So it's always wise to make the wire slightly longer. Do you need a Ballon? Well, not really to get it working, but it's not a bad idea because, for example, this is a diamond Ballon. The good thing about this is it gives a slightly better match, and it's a great way of connecting your antenna. Wire either side, SO239 for the coax, so it's an easy way of connecting and directing a dipole. One thing I would recommend though is a line isolator at the transmitter end. It's very simple to make, just a few turns of the coax round a toroid, and there's plenty of details on the internet as to how to make one. I said a dipole is a single band antenna. That's not quite true. It will work on odd harmonics, so it'll work on the third harmonic and the fifth harmonic and so forth. But the relationship of the ham radio bands is such that the only band that really makes it a multiband antenna is if you cut this antenna for 40 meters, the third harmonic will be 15 meters. So this antenna will work on 40 meters and 15 meters. Not quite as well as on 15 meters, but it's a good enough match to get you going on that band. Now, I should say that some of these antennas can be erected. In fact, all of the horizontal antennas can be erected as an inverted V. That sometimes solves the support problem, because with an inverted V you only really need one mast. If you have that mast in the centre of the antenna, it puts the centre of the antenna up high, which generally speaking is the most important part of the antenna anyway, and you can take the legs down at an angle. Also, you can squeeze antennas in by bending them around a bit. Don't be frightened of bending an antenna around. You might think, oh, well, if I bend it around, I've destroyed the radiation pattern. You know, in a small garden, there's lots of things in that garden that will also destroy your radiation pattern. When I say destroy, it just modifies it. So you might have a tree there, a house there, or whatever, and it will modify the radiation pattern. But so what? the antenna will still work. And if you're in a small garden, you have to make the best of what you've got, and it's a kind of challenge. So are there any other ways of making a dipole cover more than one band? Well, yes, there are. Let's take a 20-metre dipole. Roughly each side of that dipole is 5 metres, and we feed it with coax there. That antenna will resonate on 20 metres. We could put what we call a trap at either end, and those traps need to be resonated on the 20-metre band. When they're resonant, they're parallel traps. When they're resonant, they block any RF travelling through, so it's like an insulator, but they will pass other frequencies. So if we put the required length of wire beyond those traps, that antenna could be made to resonate on 20 metres and, for example, 40 metres, but the total length of that antenna will be less than a normal dipole for 40 metres, because these traps add loading to the antenna. So the measurement there is going to be roughly right for 20 metres, but the overall length for 40 metres will be slightly short. It's a bit of a cut and try, although you could probably find some information on the internet. If the normal length of a 40 metre dipole is 20 metres, it's probably going to end up around about 16.5, or say about 16.5 metres overall. So shorter than the normal dipole, which is quite handy because it means to say you've got a compact antenna which covers 2 bands. A dipole is capable of actually working at almost any height. If you had a dipole down at 10 feet, it will still work, but not nearly as good as it would if it was much higher. Basically, as you raise the height of a dipole, the angle of radiation reduces, and so you tend to work more DX. A dipole at 10 feet will work, but it will give you high angle radiation, and you'll only be working stations over fairly short distances. Put the dipole up to 20 feet and you'll work a lot more stations. And 20 feet, or 7 metres, is quite practical if you've got a small garden. It will work. It won't work as well as a dipole which is twice that height, but there are limitations in small gardens. You may have heard of random length of wire. A random length of wire is what the description suggested it is. It can be any length of wire. So we have a length of wire there, indeterminate length, as long as your garden. Now, quite clearly, you can't just put coax on the end there. It just won't work, because the impedance at the end there will be all sorts of different values depending on the frequency you're operating on. So you need some form of matching unit. And the best form of matching unit for a random length of wire is what we call an ATU. Some people will say it's an antenna matching unit, which it is, but ATU is the common term, and it's the term that appears on the front panel of your radio. So we call it an ATU. That length of wire goes into the ATU, and the other end of the ATU is fed to your transceiver. You do need some form of earth. And if you're operating in an upstairs room or even a downstairs room, you will need an earth. And really and truly, you need that earth to go directly to some form of copper pipe outside, so that it actually does achieve a sort of well, it's a DC earth. You'll never get a perfect earth if you're operating an upstairs room, because the 0 point of value and the maximum point of current is there, and as you go up that earth wire, so the voltage builds up. But it will prevent the voltage building up on the chassis of the transceiver. You can actually get rid of that and use what we call a counterpoise. And a counterpoise is another wire that comes down the chassis, goes down towards the earth, and then runs along the ground, or say a metre above the ground. So you've got your antenna there, and you've got your counterpoise running along there at ground level. That's basically a random antenna. You can feed it how you like. You can feed it with the ATU upstairs like that. If you're downstairs, what you can do is, let's say you're downstairs there, you've got your ATU there. You run the aerial up in the air for 10, 15, 20 feet, and then down the garden. but you still need to make sure that's earthed. And there's your end-fed wire, random length of wire, and that will resonate on virtually any band. Basically, the longer the better, but you'll find that you can resonate it on all the HF band, generally speaking. If it's short, you may struggle a bit on 80 meters, but if you can get, say, I don't know, 15 or 20 meters down the garden, even if you have to fold it around a bit, drop it down there, it will resonate. So a random length of wire really needs an antenna tuner, and that's the best way of matching your random length of wire, and it's a good general purpose multi-band antenna. Now, in feeding a wire, it's got a lot of attractions, because it means to say you haven't got a long coax run, you can have a short coax run at the house end. So let's take what was our random length of wire, and let's make it an exact length, an exact half wave. Make that an exact half wave. We'll make it an exact half wave on 40 meters. So that would be a 20 meter length of wire, which is a half wave on 40 meters. And that means to say that we've got the maximum current points in the center there. Now, I've shown it's horizontally. You could actually erect that as an inverted V. The good thing about that is there is something that is common on a lot of frequencies. On 40 meters, that point there, the feed point, is a very high impedance. It's also a very high impedance on 20 meters. It's also a very high impedance on 15 meters, and likewise a high impedance on 10 meters. In other words, this half-wave antenna will work on harmonics. So if we run out a 20 meter length of wire, which is a half wave on 40 meters, that half wave will work on 20 meters, 15 meters, and 10 meters. It's a great multi-band antenna, but how do we feed it? Well, we need a transformer, because that's a high impedance, and the output on your transceiver will be 50 ohms. We're looking at about 3,500 ohms there. A popular way of doing it is using something called a 49 to 1 unan. 49 to 1 unan. And that transmits the low impedance to a high impedance. 49 to 1 is not really a magic number. It could be 64 to 1. It could be 36 to 1. But 49 to 1 is the popular one. And there's a transformer, and that attaches to the end of the wire, and that transformer can be out in the open, providing it's weatherproof. And then you just need a short length of coax cable going back into your shack to feed it. So you've got a coax cable there, 49 to 1 transformer, a measured half wave on 40 meters, which is 20 meters long. Check the VSWR and adjust the length to get the best SWR, and that then should transform into a fairly low SWR on the other harmonically related bands. Don't forget to have a line isolator at the transceiver end. Now, if you're wondering what about vertical, well, I'm not covering the vertical here for the very simple reason I've done a more detailed video on vertical antennas, which you'll see in the next week or so. But what about another wire antenna? Well, in some ways, the best multi-band wire antenna is something called a doublet. Now, a doublet really is simply a dipole. Let's draw the dipole. We've got two halves, but instead of feeding it with coax, we feed it with something called ladder line or balance line. And ladder line, the traditional ladder line, was open wire with just joiners there, insulated joiners to space it out, spacers, there we are. And that's called a doublet, but basically it's a dipole fed with ladder line. If we make this antenna, we'll talk about 40 meters again. If we make this antenna 20 meters long, it's a dipole on 40 meters, and it has a radiation pattern that you would expect for a dipole. Basically, a dipole has got sort of lobes like that, and the area runs through the center. So we have a dipole, but we're feeding it with ladder line, and that point, the feed point at the bottom there, can be anything really in terms of impedance and reactance. It depends on how long that ladder line is. So the good thing about ladder line is there's very, very low loss. It doesn't really worry too much about VSWR. You can forget VSWR, there's very, very little loss. The trick is matching it. The impedance up there is really of no consequence at all. The important thing is that we have an antenna matching unit that will match that. Now, most matching units have either a coax output or have a balanced output. If they have a balanced output, then you can connect your ATU directly to this balanced feeder line. A lot of ATUs don't have balanced inputs, so what you need is a Ballon. Now, a Ballon can be very similar to this. This is a 1-to-1 Ballon. I normally use something called a 4-to-1 Ballon. It's not that critical actually, but the point is that the coax cable to the transceiver goes there, and your balance line goes across the Ballon there. So you need either an antenna tuner with a balanced input where you can make a direct connection, or you need an ATU with a coax connection and then a Ballon. Now, the good thing about going for the second option of an ATU and a Ballon is that the ATU can be situated inside, and then you can have a short length of cable. So you can have your ATU in the shack there. You have a short length of coax cable going there. Then you have your Ballon there, and then you have your balanced line coming down there. So ATU in the shack, length of coax cable going through the wall. Outside you've got a Ballon on the side of the wall or wherever, and then you've got your balanced line going up to your antenna. Now, I said before that this wire is, or for our purposes, is 20 metres long, which means to say it's a half wave on 40 metres. We can make that antenna work on virtually any frequency. All we need to do is to adjust our antenna tuner unit or antenna matcher unit to match it. So if we change our frequency from 40 metres to, say, 30 metres, we then resonate our antenna matcher unit there to 30 metres, and we get current going up the ladder line there, and the antenna radiates. And likewise, we can change our frequency to 20 metres, still with our same length of line, and that length of line will radiate on 20 metres. The only thing that happens is, as we change frequency, so the pattern of radiation changes. So as we go higher, instead of having this sort of donut radiation at right angles to the run of the antenna, it starts to break up and we start to get lobes. Now, the lobes can work in our favour or not. If we get lobes, we tend to get a slight amount of gain in the low direction, but we also get a null. You really can't control that, because the only way you can control where the lobes are is by moving the antenna, and if you've got a small garden, you can't really move your antenna that easily. Now, we've looked at a doublet, and a doublet has balanced line, ladder line, whatever you like to call it. I tend to use 450 ohm ladder line. We sell that down at our Portsmouth store, and it's the most popular form of balanced line. It's very lightweight, it's very tough, and it does the job done. So ladder line 450 ohm is what I would suggest. And I mentioned about supporting it in the centre in form of an inverted V. Well, now, if you've got a metal mast at the centre, you don't want ladder line coming down there, because ladder line is a little bit fussy when it gets near conductive surfaces. Ladder line should really be kept away from metal surfaces, at least about 1 metre. So how do you do it? Well, it's quite easy. What you do is you feed that antenna slightly off centre. So instead of the mast being in the absolute centre of the antenna, you move it to one side, or you move your antenna so that the ladder line is about about 1 metre away from the mast or more. So your ladder line is actually about 1 metre away from the centre point of your antenna. That doesn't make a heap of a difference, but it gets that ladder line away from a metallic mast. So that's one easy way of using an inverted V with a ladder line and a metal mast. Now you might say, well, I've got an antenna tuner in my transceiver. Well, yes, you have, and you might get away with having your ladder line coming down to near the window, and then a Ballon there, and then a length of coax cable going straight into your transceiver, because your transceiver's got an antenna tuner built in. The only problem is that the built-in ATUs in transceivers don't have as wide a range of matching as an external one. So by all means try to use the one in your transceiver, and you'll probably find on certain bands it will work and on some bands it won't. If it won't work, there are options. You can actually change the length of this wire a bit, make it a bit longer, a bit shorter, to see what happens. You can actually change the length of the ladder line as well. Both of those will actually affect the ability of the matching unit to match, but generally speaking, it's not very easy to change the length of the ladder line, because the length of the ladder line is determined by what is convenient to run from your aerial in the air to your Ballon or ATU. So the easy way is to adjust that. But bear in mind that if you adjust the antenna length by, say, a metre or so, you will affect other bands. So you may get into a situation where you correct it on one band, but then the other band is thrown out. Basically though, if you use an external antenna matching unit, it will probably match whatever you erect. Now, you don't need to have a half wave. That's not a magic length. The only magic about that length is on the length of which is a half wave, it gives a predictable radiation pattern. But if you're in a small garden, you probably want to get as much wire as you can out. So the length of that really doesn't matter. It really doesn't matter. The actual impedance at the bottom there is determined by the length of that and the length of the ladder line. And hopefully your matcher can cope with that. So if you can get more than 20 metres down the garden, increase the length. And also, if you can do it, then why not drop the ends down a bit? That gives you a longer antenna. Now, the longer the antenna is, the better it's going to be at lower frequencies. I said this antenna was covering 40 metres and there was a 20 metre long dipole. You will be able to resonate that probably on a lower band. So if, for example, it resonates on 40 metres, you might be able to resonate it on the 60 metre band. Forget these bits at the end at the moment, imagine they're not there. So we've got a dipole which resonates on 40 metres. On 60 metres, the point of maximum current, instead of being there, it's going to be halfway down the ladder line, but it will still work, it will still radiate. So the good news about a doublet is that not only will it work on what is a half wavelength at the top there, it will also tend to work on frequencies below that. So always give it a try. It may mean to say that you could actually, if you drop the ends down a bit, you may actually be able to get on 80 metres as well. So there we are. Doublet is a very universal antenna. So that, in a fairly compact video, is my take on simple multi-band wire antennas for a smallish garden. As I said at the outset, winter's drawing on. It's not a bad day today, and we do get some good days in the winter. The other thing, of course, is we get short days, don't we? It gets dark at about, what, 4:30? Gracious me. So it's a good time to get out in the garden before we get into the real heart of the winter. Remember, amateur radio is a great hobby. The antenna is one of the most important things that you use in an amateur radio station. So get it right. So, thanks for watching this video. I hope it's been helpful. And thank you for subscribing to the channel. It's greatly appreciated. Don't forget that down at Portsmouth we've got a great range of equipment and we'll do some deals. So pick up the phone and speak to one of the sales guys down there. Say that you spoke to me and what can they do on the price and so forth. There we are. Take care. Enjoy ham radio. Speak soon.